Hi, this is Helping Otters. My name is Dan Sedano. We have Lindsay Reynolds, Max Albert, and Ricardo Barbosa. And our title of our project is My Achy Breaky Heart. We chose this project because, according to the CDC, 655,000 Americans die from heart disease every year, which is 1 in 4 Americans. This is one person every 36 seconds. By knowing the risk factors of cardiovascular disease, one can make better choices to avoid heart failure. We originally hypothesized that age, high blood pressure, and sex were some of the leading factors in cardiovascular disease. We tested this hypothesis and found that there were other factors unknown to us that contributed highly to probability of dying from cardiovascular disease. Based on the initial raw data visualization, specifically the heat map, we updated our hypothesis to say that high levels of serum creatine, age, ejection fraction, and serum sodium would increase the likelihood of cardiovascular disease. Our research question is, what is the percent likelihood of someone dying from cardiovascular disease based on a specific high impact risk factors?
The source of our data set was from the University of Irvine. Our data includes 299 clinical records, including 13 medical features relating to heart disease. This data set has no NA values, and we did not need to do any feature engineering. The data set documentation suggests to drop time from our table because it is not relative to our project.
In order to complete this project, we used Kaggle to find and download our dataset to GitHub. We then used Google Colab in order to create our model and visualize, manipulate, and understand our data. So let's walk through our data visualization. We first plotted a heat map. From this heat map, we were able to see which features were most negatively correlated and positively correlated to a death event. From this information, we plotted a histogram of ejection fraction to see how it affected the death count. We found that lower levels of ejection fraction resulted in a higher death. According to heart.org, ejection fraction is the percentage of blood that the left ventricle pumps out with each contraction. Normal range is between 50 and 70%. Next, we plotted a histogram of serum creatine levels and how they are affected, or how they affect death count. We found that lower levels of serum creatinine resulted in higher death count. Serum creatinine is used to measure renal or kidney function. Then we plotted both of these highly correlated features onto one graph to see how they were both related to death events.
We used the two most negatively correlated features and three most positively correlated features from the heat map. We used trial and error to determine that a max depth of 3 and a minimum sample split of 10 gave us the most accurate results. We found that some of our leaf node samples were as small as 0.4%, which may have indicated overfitting. Because of this, we will add other hyperparameters, minimum sample leaf, to avoid this as we tune our model. We also found that the most important features in this model were age serum creatine, ejection fraction, and serum sodium.
In order to further fine-tune our model, we decided to use a greedy algorithm to determine the best features. When we ran our algorithm, we found that after just 2 features were added, the accuracy of the model no longer improved. Those 2 features turned out to be ejection fraction and serum creatinine. We used these 2 features to create a second test model. Looking at the crosstab graph, we can see that our accuracy has improved compared to our first test model.
On the third test case, once we knew which features to use in our model, we decided to use a grid search in order to fine-tune our hyperparameters. This came back saying that a max depth of 2 and a minimum sample split of 2 were the best hyperparameters. Looking at the cross-tab graph, however, it is clear that this model gives a high number of false negatives and is not providing higher accuracy than our previous test model.
Based on our 3 test models, it is clear that our second test model was the most accurate. This model used the 2 most correlated features, a max depth of 3 and minimum sample leaf of 10. Using our final model, we were able to test our hypothesis by running predictions using example test data. Each test case provides the percent likelihood of death given the sample data.
What might the answer imply and why does it matter? Our final result implies that a person's serum creatinine levels and ejection fraction levels are the most impactful risk factors. Age and high blood pressure were not as influential as we initially hypothesized. According to the CDC, high blood pressure is a major risk factor for heart disease. Our data shows a correlation as well, but we did not find that it was the major factor. Other research also shows that unhealthy blood cholesterol levels are a major factor. However, cholesterol is not a factor listed in the data collected in our data set. Because our data set was so small, it was hard to determine exactly how impactful some of the other features were. For future research, we feel that increasing the size of training data would allow for more accuracy and exploration. We chose to use Google Colab for this assignment because it was easy to work with for our group project. We were able to work at the same time and easily see updates in comparison to other development environments. In summary, serum creatinine and ejection fraction were the most impactful features in terms of increasing the accuracy of our model. For further research, our model has high variance, which indicates that it might be too flexible. We need more data in order to close the gap between the test and training set accuracy. Thank you.